Hello everyone. So let's now solve question number 8, 9 and 10. So these are comprehensive type question. So let's read through the data first. In genetics, a classic example of dominance is the inheritance of seed shape, pea shape in peas. Peas may be round, associated with genotype capital R, or wrinkled, associated with genotype small r. In this case, three combinations of genotypes are possible: double capital R, small capital R, and capital R, small r. The double capital R individuals have round peas, and the double small r individuals have wrinkled peas. In the capital R small r individuals, the capital R genotype masks the presence of the small r genotype, so these individuals also have the round peas. Thus, the genotype capital R is completely dominant to the genotype small r, and the genotype small r is recessive to the genotype capital R. First, assume the crossing of double capital R with double capital R. This always gives the genotype double capital R. Therefore, the probabilities of an offspring to be double capital R small r, and the double small r respectively are equal to 1, 0, 0. Second, assume crossing of capital R small r with double capital R. The offspring will have equal chances to be of genotype double capital R and the genotype capital R small r. Therefore, the probabilities of capital R small r, and double small r respectively are 1 by 2, 1 by 2, and 0. Third, consider crossing of double small r with double capital R. This always results in genotype capital R small r. Therefore, the probabilities of genotype double capital R small r, and the double small r respectively are 0, 1, and 0. This can be viewed as the following table. So, all the data above about the probability we have noted down in the table form here. That is the crossing of double capital R with double capital R. Then the genotype offspring for double capital R will have probability 1. For capital R small r will have probability 0. For small r, it will be a probability 0. And similarly for these two crossing also. Now, question next says is, the matrix representing this observation is given by P. So, this data we have formed in the matrix form and name it as P. Let the probabilities of double capital R, small r, and double small r in the initial addressed t equal to 0. Sample space B x01, x02, and x03 respectively. This is represented by the initial distribution vector, which is a 3 cross 1 matrix, is denoted by x0 like this. For any positive integer n, the distribution vector after n generations at t equal to n is denoted by xn and given by the equation p times xn minus 1 is equal to xn, where p is our this matrix given above. Using the above information, answer the following questions. So first, let's look at question number 8. So question 8 says, find out the correct set of options from the following. So they are asking about the RREF form for P and P square. So our P matrix given is 1, 1 by 2, 0, 0, 1 by 2, 1, and 0, 0, 0. Let's try converting this in RREF form. So this is already 1, so it's the leading entry. For second row, this is the leading entry, so we have to make it 1. So that we can do by multiplying second row by 2. So we get Now, this matrix is now in REF form, but we have to make it in RREF. So that's why we have to make this entry as 0. Because for RREF, there's one more condition that for each leading entry in every row, that should be the only non-zero entry in its corresponding column. So for second row, this is the leading entry. And with respect to that, in its column, this entry we have to make it 0 as it is not 0 yet. So we can make it by our row operation, that is 1 by 2 times R1 minus 1 by 2 times R2. So 1, 0, 0, 0. So it will be minus 1. So now this matrix is in its reduced row echelon form. So it matches with option third. So option third is correct, while option 4 about the echelon form for the P matrix is wrong. We can also directly identify about the option for that this matrix here is not in its RREF form. As for third row, this is the non-zero leading entry, and for it, this is not the only non-zero entry in its column, as these entries are not 0. So this matrix is not even in RREF form. So this option is anyway wrong. So now let's look at for P square also. So P square would be our P matrix here 1, 1 by 2, 0, 0, 1 by 2, 1, 0, 0, 0 times 1, 1 by 2, 0, 0, 1 by 2, 1, 0, 0, 0. So multiplication of these two matrices will give us P square as 1, 3 by 4 and 1 by 2, 0, 1 by 4, 1 by 2, and this is 0, 0, 0. So this matrix now is our P square, and we have to row reduce also. So first we will make this entry as 1 by multiplying second row by 4, 1 by 2, 0, 1, 2, 0, 0, and 0. Now this matrix is in in REF form. Now we have to make it in RREF also. So for that, we have to make this entry as 0. So for that, we can do R1 minus 3 by 4 R2. So 1, 0, minus 1, 0, 1, 2, 0, 0, 0. So now this matrix is in its RREF form. And if you observe this matrix, that is the RREF of P square, and this matrix, that is the RREF of P, are same. So RREF form, that is the reduced row echelon form of P and P square are same in this case. So option 2 is also correct. And option 1 is wrong. Let's say that they are different. Now next solve question number 9 using the same data. Suppose after 2 years the distribution vector x2 is calculated to be this, and the initial distribution of capital R is 1 by 3. Find out the initial distribution of capital R small r and double small r. Now we have given our initial distribution vector x naught as this. So given x naught is x naught 1, x naught 2, x naught 3. Okay. Let x naught 1, x naught 2, naught 3 equal to x, y, and z. We are using this notation for the simplicity case. Now we have given x2 as this matrix, and we have the relation between the distribution vector and our matrix P, that is given by this equation. that is p xn minus 1 is equal to xn. Now for n equal to 1, it would be p x naught equal to x1, and for n equal to p x1 equal to x2. Consider this as equation 1, this is equation 2. On multiplying, let's write it as pre-multiplying equation 1 by p, and we get pp x naught equal to p x1, that is p square x naught equal to x2. From second equation, that is p x1 equal to x2, so we have put that value here. So from second. Now we have p square matrix that we calculated above. That is our this matrix here. So 1, 3 by 4, 1 by 2, 0, 1 by 4, 1 by 1 by 2, 0, 0, 0, and our x naught, we have considered that that is x, y, and z, and this is equal to x2. So we have given x2 to be this. So 3 by 4, 1 by 4, and 0. So basically we have to solve this system of linear equation, but we have given one more equation, one more information, that is initial distribution of capital R, capital R. Remember that the initial distribution probabilities for capital R is denoted by x naught 1, and that is, in our case, we are denoting it with x. So we can write this as 1, 3 by 4, 1 by 2, 0, 1 by 4, 1 by 2, 0, 0, 0 times 1 by 3 y z equal to 3 by 4, 1 by 4, and 0. So now we have to solve this system of linear equation. So let's try formatting the augmented matrix. That is 1, 3 by 4, 1 by 2, 0, 1 by 4, 1 by 2, 0, 0, 0, 3 by 4, 1 by 4, 0. So if we try row reducing this matrix, that is first multiply second row with 4, 1, 3 by 4, 1 by 2, 3 by 4, 0, 1, 2, 1, 0, 0, 0, 0. Now let's make this entry 0. So R1 minus 3 by 4, R2. So 1, 0, minus 1, 0, 1, 2. Okay. It would be 0, 1, 0, 0, 0, 0. So now we have our augmented matrix in reduced row echelon form. So from here we get x minus z is equal to 0, which implies x is equal to z, and from this we will get x plus 2z, sorry, y plus 2z is equal to 1. So now x is equal to z, that means z is equal to 1 by 3, as we have given x value to be 1 by 3, and y plus 2z is equal to 1. So we get y plus 2 by 3 is equal to 1. So y is equal to 1 by 3, where y denote the probabilities for capital R, small r, and z denote the probabilities for small r, small r. Let's look at the option. The initial distribution for capital R small r is 1 by 3. So that was the value of y that we got. So it is correct. Initial distribution for small r is 0. We got it to be 1 by 3. So second option is wrong. The initial distribution of capital R and small r are equal. So this is correct. Cannot be determined from the given information. That is obviously wrong. Now let's solve the last question. That is question number 10. So suppose after 3 generations, the distribution vector x3 is calculated to be 1, 0, 0, and recall that 0 is less than equal to x01, x02, x03 is less than equal to 1, as these basically denotes the probabilities, and probability always lies between 0 and 1. Find out the correct set of options. So we derived one result before in question 9, that is p square x0 equal to x2. So for x3 simply we can write it as p cube x0 equal to x3. So we have our p square matrix as 1, 3 by 4, 1 by 2, 0, 1 by 4, 1 by 2, and 0, 0, 0. So for p cube we can do 1, 3 by 4, 1 by 2, 0, 1 by 4 by 2, 0, 0, 0, multiplied with our p matrix, that is here. So 1, 1 by 2, 0, 0, 1 by 2, 1, 0, 0, 0. So this we will get is 1, 7 by 8, 3 by 4, 0, 1 by 8, 1 by 4, and the last row is 0. So this is our p cube matrix. Now again our x0, that is the initial distribution vector, is denoted by x01, x02, x03, and again we will use the notation x equal to x01, y equal to x02, z equal to x03 for the simplicity of our equations. So our equation is p cube x0 is equal to x3, and x3 was given as 1, 0, 0. So p cube 1, 7 by 8, 3 by 4, 0, 1 by 8, 1 by 4, 0, 0, 0 times x by z is equal to 1, 0, 0. So let's form the augmented matrix. 1, 7 by 8, 3 by 4, 0, 1 by 8, 1 by 4, 0, 0, 0, and 0, 0. Now let's try row reducing the matrix for our solution. So that is 8 times R2 we can do. Let's run here. 1, 7 by 8, 3 by 4, 0, 1, 2. Here it is 0, 0, 0, 0, 0. And R1 minus 7 by 8, R2 for making this entry as 0. So it is simply 1, 0, minus 1, 1, 0, 1, 2, 0, 0, 0, 0, 0. So now the equation that we got is x minus z is equal to 1, y plus 2z is equal to 0. So now from these two equations we get is x is equal to z plus 1. Consider this as equation 1, and y is equal to negative 2z. Now recall that x, y, z are our basically x01, x02, x03, and as these are probabilities, so they will always lie between 0 and 1. So that means x, y, z R lies between 0 and 1. We have given x is equal to z plus 1. So we will get is x will be greater than equal to 1 as z will be greater than equal to 1. So for like any value where z is greater than equal to 0, x would be greater than equal to 1. At z equal to 0, x would be 1. And for any value greater than 0 for z, the x would be greater than 1. So in the case of z would be greater than 0, x would be also be greater than 1. But we also have to make sure that x and y and z lies between 0 and 1. That is, we also have the equation x is less than equal to 1 for 0 and z is also lies between 0 and 1. So that means from these two results we will get is x is equal to 1 and z equal to 0. And on putting this result in equation second, we will get y equal to 0 from second. So our initial distribution vector x naught is 1, 0, 0. So let's check the option. The initial distribution vector x naught is 1, 0, 0. So option 2 is wrong. Option 3 is also wrong. And option 4 is also wrong, as x naught can be determined from the given function. Now option 5 and option 6 are about x naught equal to xn for all positive integer n, or there can be some positive integer n for which x naught is not equal to xn. So we have found x naught. So let's try finding x1, that is equal to p x naught. So our p matrix was here 1, 1 by 2, 0, 0, 1 by 2, 1, 0, 0, 0. If we multiply it with 1, 0, 0, here it is our x naught and this is our p, so we will get our x1. So if we do the multiplication, we'll get 1, 0, 0. Now we have our x1 to be 1, 0, 0. So let's try checking for x2 also. So x2 is p times x1. So again our p matrix would be same. And as our x1 is also same as x naught, so the result for x2 would also be same, that is 1, 0, 0. And that is in fact would be that x naught would be equal to xn for any n positive integer, as the p is always our constant, that it would be the same matrix, and as the result we are always getting 1, 0, 0. So for any recurrent solution you will get the same distribution vector as x naught. So the option 5 is correct and option 6 is wrong. Thank you.